And so this is some delving deeper into the absolute value function. I'll do 3 problems because they're kind of lengthy. That way we'll keep the video manageable in terms of time. So the first, these are the questions I'll be asking you to do: sketching absolute value functions, writing them as piecewise functions, solving them for a given altitude, and solving them as an inequality. So the first one we've been doing right along. It's good to keep doing them. It, I think, smooths out those neuronal pathways. So cup shape up. 5, 7 vertex, which means that the y-intercept is on this side. And if we put in a 0, absolute value measures distance from 5. How far is it over here to 0? 5 steps. If we double, makes it 10. We had 7, 17. So 0 gives us 17. And the symmetry of it, 10 should get us 17 as well. Let's just try it. 10 minus 5. 10 is also 5 steps from 5 on the number line. Double 10 plus 7, 17. All right, nothing new there. Now these arrows simply mean as I move in the negative direction, my y values are going up, which implies that I move in the positive direction and come down. So this is one branch. I'll erase the other branch. I'll highlight the x value here. I'll get rid of the y for a moment. Looks like I have a decreasing linear function. I'm going to get rid of that arrow. I have a decreasing linear function until I get to 5. And so what is that function? Well, just get rid of the absolute value symbol. Going down at 2 to 1. Now we can see that, right? Let's bring this back. 17 minus 7 over 0 minus 5. y2 minus y1, x2 minus x1. We can see it's a slope of -2. X minus 5 plus 7, but that only happens for x values that are less than or equal to 5. And then what happens? We get rid of that branch, and we look at that branch, which is going up at 2, right? 7 to 17 is 10 units of change, 5 to 10 is 5 units of change. Going up to 2 to 1, x minus 5 plus 7. That's only happening when x's are greater than 5. Okay? So we're decreasing to 5, 7, and then increasing to infinity. All right, so why is that helpful? Well, now we can solve equations using the branches, and we don't have to think. And people make mistakes all the time solving these absolute value equations with the plus minus kind of textbook method. So let's just use these 2 branches. We're pretty good at solving linear equations at this stage. Don't think anybody's having trouble with that. So let's just set them to 15. The 2 branches, minus 2, x minus 5, plus 7. What does that equal? 15. And the other branch is positive 2, x minus 5 plus 7 equals 15. Right, so we're going to solve those 2 equations. I know, bring the science cart down a little bit, capture it all. Piece of cake. 8 divided by -2, -4. Add 5, 1. So it looks like 1 gets us a height of 15. Oh, well, that makes some sense. Here's 17 right here, right? 15 is less than that. So yeah, 1 comma 15 seems to be positioned properly. And there's shortcuts to this process. And I'm going to let you find them. I'm not going to take them right now. But you know, looking at mathematical situations and finding easier ways to do something and quicker ways to do something is part of the learning process. I don't want to take that away from you at this stage in the second half. You tell me the shortcuts you find and keep your eyes open. But let's just continue here. 8, 4, 9. Okay, so 9 gets us 15. Oh yeah, 9 is a number to the left of 10. So it looks like it's graphed properly. All right, so we just found our answers to f of x equals 15. And those answers are x equals 1 and 9. And x equals 1. So now what's the next step? The next step is, when am I bigger than 15? I can already see 0 and 10 get me numbers bigger, but let's formalize it with a number line. Let's put 1 in, let's put 9 in, and we're looking at linear functions, which means we have sign changes. So once we know one answer, we probably know the others, not probably, we do. But let's just trial and error. All right, let's go back to the original. Let's pick a number bigger than 9. I love a million. You might have said 10, whatever. Gonna get the same result. The absolute value of a million, it's a million times 2 is 2 million plus 7. And 2 million plus 7, I believe, is bigger than or equal to 15. So that's true. And this is going to be false, and that's going to be true. We can already try a number between 1 and 9. We already got one, 5. 5 gets me 7. 7 is not bigger than or equal to 15, so that was false. And I think we can see that graphically, 15 is this height right here. And I'm above it, not with those numbers, but I think we can start to see from a graphical standpoint, that I'm above, so that's true. And that's the 4 questions I'm going to be asking. So let's do it again. Let's go to another function. And you pause the video and you try, and I'll just do the answers. Let's see. Okay, so, yeah, all right. So we're going to find out what the sketch looks like and immediately see the multipliers and negatives. So increasing on the left, decreasing on the right. All right, so I'm not going to put the arrows in here. I'm going to put a big dot there for the vertex, -4, 10. And now I'm going to write it as a piecewise. I want to get the y-intercept here. Gives me a frame of reference. So 0, -8 plus 10. I'm sorry. Yes, -8 plus 10. +2. So 0 gets me 2. Well, that's good because 2 is smaller than 10 and 0's to the right of -4. So folks have had some trouble positioning some of their data. So we'll stress that. I'll put the arrows in here just to make it. All right, I'm on the increasing side. So g of x has a Alfred Hitchcock piecewise function is positive, increasing. So I'm going up at 2 to 1. X plus 4 plus 10, but that stops when I hit an x value of -4. So I'm on the smaller side of -4, and then I'm decreasing to x plus 4 plus 10 for x values that are greater than or equal to negative. I got to put the equal on one of them. Now we're going to find out -40. When does this function equal -40? So we'll use the pieces. And the pieces are 2x plus 4 plus 10. I can sneak that in there. Equals -40. And then -2x plus 4 plus 10 equals -4. So I'll subtract 10. -50. Divide by 2. -25. Subtract 4. -29. Okay. Subtract 10, -50, divide by -2, +25, subtract 4, 21. And just a trick of the trade, 21 plus 29 divided by 2 is equal to, I wanted the heights, excuse me. Oh, -29, that's why this is, okay. So 21 minus 29 is -8 divided by 2, which is -4. That seems to be a really important number. Oh yeah, makes the zeros. And that's the smallest distance you can travel from -4 is 0. So just a quick check to make sure you didn't make any careless errors. Usually do in a video. I'm not all that good about talking about these things and computing at the same time anymore. I'm getting old. All right, so where were we? Oh, we want to know when we're less than -40. Well, I think we can probably help ourselves graphically. So -40. What am I smaller? Oh, these x's. Those x's get me smaller than -40. Did I want or equal to? No. So let's make our sign chart, what we did before. Let's put our answers, negative 29. And let's put 21 in here, and let's put 22 into the function. Going back to the original. Let's put 22 in, although I like to put in 1 million because that gets me minus 2 million. And minus 2 million is less than negative 40. So I know that this is going to be true. But let's check it with 22. That might be more useful for you. So minus 2 times 26 plus 10. True or false? Less than negative 40. Well, minus 52 plus 10 is minus 42. Is that less than negative 40? Yes, it is. And you're going to find that they alternate. I don't know, I said I wouldn't show you the patterns, but there's one. They alternate. And I think 0 is probably the easiest number to plug in between negative 29 and 21. And if we put a 0 in here, I think we can see that negative 8 plus 10 is not less than negative 40. That's why we say false. You try to put a number in smaller than negative 29 to prove that's true. And I forgot to write these in interval notation. I'll be asking you to write them in interval notation. So what's this in interval notation? Open circle in that direction, open circle in that direction, and the interval notation is negative infinity to negative 29, union 21 to infinity. Yeah, I'm going to help if I put that up a little higher. So negative infinity to negative 29, union 21 to infinity is the way we can write this information in interval notation. All right, so one more. Remember, the smallest distance you can travel from a number is 0. And so I'm looking for this to become the absolute value of 0. And I think we can see that 10 makes that happen. So this is a positive V shape up. And 10, negative 8 is our vertex. So our y-intercept is to the left of 10. I always put it right in the middle. So I put a 0 in and I get the absolute value negative 30 is 30, times 2 is 60, minus 8 is 52. And that's helpful because it gives us a guide here. We're going to be working with finding heights of 22, so we know one of our answers has to be somewhere between 0 and 10 for the x's, right? This height of 22 is between these numbers. All right, so let's go find them. The way we can find them is to write this as a piecewise function. Didn't leave myself much room here, so I'll do the piecewise. Yeah, I think I'll put it below. That's where I've done with each of these. So h of x, there's my friend Alfred. Yeah, I am following the graph, looking into the future, decreasing. Okay, so what am I decreasing? I'm decreasing at 2 parentheses 3x minus 30 minus 8. X is less than 10. All right, so that's that function. And we can clean it up if we want. If we clean it up, we should get negative 6 x minus 10 minus 8. All right, if I pay you $3 an hour and I take away twice your pay, well, that's so mean. You're losing $6 an hour. Mean thing to do. Anyway, so you can write it that way if you want, but there's no reason to. You can just leave it. And then you're increasing on the other side too. 3x minus 30 minus 8. And that's for x values greater than or equal to 10. I like this method because I don't feel like I have to think. I don't have to give it any thought. All I'm doing is changing the absolute value symbol to parentheses and putting a plus and a minus on the board. All right, so let's solve this for 22 using our pieces. So minus 2, 3x, it's a little extra writing, and I don't usually like extra writing. But I kind of like the fact that I don't have to think, because then I won't make a thinking mistake. All right, so let's get this one first. 30, divide by negative 2, negative 15. Add 30, positive 15, divide by 3, 5. 5 should work. So let's put 5 in just to make sure, because it's the end of the video. And I always make a stupid mistake in videos. So let's see if I did here. 3 times 5, 15, minus 30, negative 15, the absolute value of negative 15. 15 times 2 is 30, minus 8 is 22. Oh, how nice. And now we're going to use the eraser. And I'm going to solve this. Okay, so first step's the same. And now I've got 230 is positive 15. I'm going to add 30, which is 45. Divide by 3, which is 15. And what are the numbers between, what did I get for an answer? I didn't write my answer down last time. Oh, God almighty. Yeah, brain got tired. All right, so I think it was 15 and 5. X equals 5 and 15. Of course, if I add those up, I get 20 divided by 2, which is the number 10. Geez, I wonder if the number 10 has significance here. I guess it does. So I didn't make any mistakes. And now I want to decide, using 5 and 15, when I am what? When I am less than 22. Less than 22. I can kind of tell from the graph already. We got a 10, we got a 50. 0 got us 22, so 20 should get us 52. Yep. All right, and 5 and 10, those x values, 5 and 15, geez, they do seem to be symmetric to 10, yeah. All right, so I'm belaboring the point, my apologies. So let's just put 5 and let's put 15, and let's find that it's false true. And you can go ahead and check it. Let's pick a number like 100. Let's pick 100 this time. Let's put 100 in there. Let's put 300 minus 30. You know, it's a big number times 2 minus 8. Is that number less than 22? Absolutely not. 0. If I put a 0 in, I already got negative 8. Is negative 8 less than 22? True. And you'll find that they alternate. And so that that's what you'll be doing every day and on every test until May 15th. And hopefully you get very good at it and can answer those questions in a minute or less. And that'll be that. All right. Practice is over.